Okay, so someone asked me to do homework 16, question 9. Okay, so it says f of x is this, g of x is this, find f plus g, f minus g, f times g, and f divided by g, and give the domain of each. Okay, so let's start with f plus g. F plus g of x is equal to f of x plus g of x. So then I go 3x squared, minus 2x plus g of x. And I can add this and this and this and this. So 3x squared plus 1x squared is 4x squared. I lose 2, I lose 1, I lose 3, plus 3. So that's f plus x. So now let's do f minus g. That's the same as f of x minus g of x. So 3x squared minus 2x minus x squared minus x plus 3. Is that correct? Yeah. So I have to distribute this minus throughout first. So let's take the brackets off this. 3x squared minus 2x. This times this is minus x squared plus x minus 3. This and this goes together. This and this goes together. So I have 3 and I lose 1. So I have 2x squared. I lose 2 but I get 1. So I only lost 1x minus 3. Oops. Drill line right through it. Let's do f times g of x. That's f of x multiplied by g of x. Let's draw that line better. Oh, this is going to be long. 3x multiplied by. So now I have to do the 3x squared times this, times this, times this. So 3x squared times x squared is 3x to the 4. This times this is minus 3x. How many x's do I have? I have 2 here and 1 here, so we have 3. This times this, 9x squared. Now I have to do this one times this, this times this, this times this. So minus 2x times this, that's minus 2, and I have 2 x's here and 1 x here, so I have 3 x's. Minus 2 times minus 1 plus 2, I have an x and an x, so I have x squared. Minus 2 times 3, that's minus 6, and I just have 1 x. So there's only one 4, x3, x3, x squared, and he's by himself. So I have 3x4, I lose 5x3s, I have 11x squared minus 6x. Now I have to do divide. F divided by g of x. That's really f of x divided by g of x. Let me sharpen my pencil. So, oops, it broke. Just a minute. Okay. So f of x goes on the top, and g of x goes on the bottom. Can I simplify it? I'm going to check to see if I can. So remember this from last year, last semesters, to see if I can factor this. Maybe I can factor this. Maybe I can factor this. So here I can take an x out. So I have 3x minus 2. Maybe I can factor this. No, I can't. Well, I don't know if I can, but I'd have to get the same on the top and the bottom. And I can't get something that looks like this because there's a 3 in the front. So when I factor this, I would have an x and an x. There wouldn't be a 3 in the front. And I can't just take an x out because there's no x here. So I can't factor this any more than it already is. So halas, I'm done. Okay. Okay. So now I've added, and subtracted, multiplied, divide. So now I have to find the domains. So first I find the domain of f of x. So what is f of x? 3x squared minus 2x. Well, because this is a 2, the biggest exponent's a 2, I know it's a parabola. And because this 3 is positive, I know it's a parabola that goes up. I don't exactly know what it looks like, but I know it goes up. So if I want my domain of this goes on forever and ever up. So I'm going to use all my positive x's. And here, this goes forever up and up, so I use all my negative x's. So my domain for f of x is negative infinity to infinity. Now I'm going to do the domain of g of x. G of x is equal to x squared minus x plus 3. Well, because the biggest exponent on these variables is a 2, I know it's a quadratic function, so I know it's a parabola. Because it's positive here, I know it's going to open up. And again, my domain is going to be negative infinity to infinity, because it's a parabola. Okay, so if I want to find my domain of f plus g, f minus g, and f times g, I just have to do the intersection of these two. Well, they're the same. So the domain for this new function here is just the same, negative infinity to infinity. The domain of this new function here is just negative infinity to infinity. The domain of this function here is negative infinity to infinity. Now the domain of this one, it's this, but I have to check, because I have a fraction, just let me pause the video for a second. Okay, so remember that when I have a fraction and I'm finding domain, I can't have the bottom equaling 0. It's a problem. So I have to take whatever this is and say you cannot be equal to 0 and solve for x. So I have to say for this one, only for divide, I have to say this cannot be equal to 0. Okay, so down here I'm going to say x squared minus x plus 3 cannot be equal to 0. And now I have to solve for x, which means I have to factor it. Okay, so you can try factoring. Remember we did this last semester. We can do this. Okay. Or first we can check the discriminant. This is a paper that we used last semester. So remember the discriminant? This thing here. If you put A, B, and C into this, and then if it's bigger than 0, it tells you something. If it's equal to 0, it tells you something. If it's less than 0, it tells you something. So this is a horrible question, because I wouldn't ask you something like this, because this is too complex. It's too many steps. Okay, but let's finish it. So just knowing that on a test, I would never give you something that's this difficult, because it's way too many steps. So this is A. So A equals 1. B equals negative 1, and C equals 3. So my discriminant, hold it here, my discriminant is B squared minus 4AC. So B is minus 1, A is 1, C is 3, squared, so that's 1 minus 4, 4 times 1, that's 12. Minus 12, that's equal to minus 11. So my discriminant is a negative number. Negative. Okay. So when the discriminant is a negative number, it means there's no real solutions. So it means you cannot factor it. Okay? Which means both answers are, the answers are going to be imaginary. And if the answers are imaginary, it means you can never factor it to have it equaling 0. There's no real solutions. So this can never be equal to 0. It just doesn't happen because you can't factor it. So because this says it's negative, it means we'll never have this equaling 0. So this is not a problem. Here, there are no restrictions down here because this will never equal 0. So for the domain for this one, it's also this, because this is never going to be equal to 0 because we checked using the discriminant. However, I'm never going to ask you a question like this. I'm so sorry. Who is your teacher that assigns you questions like this? This was awful. Okay, so I would give you something easier. It would be like, I don't know, x plus 3 on the bottom, and you say, this can't equal 0. So you would go, you would say, oh, that can't equal 0. And you say, oh, I have to add this restriction. So I'd give you something like this, and you'd say, oh, well, if x can't equal 3, okay, this is something more realistic that I would give you. You say, oh, x can't equal 3, so my new domain would be negative infinity to 3, union together with 3 to infinity. You would have to remove 3. But here it says, this can never be factored, so this can never be equal to 0, so we don't have to change any restrictions for our domain. But I would give you something that you could next time because this is complicated. Sorry.